All right. So, did everyone get a practice guide? Everyone's got one? I didn't forget anyone. Sorry if I did. Okay. As you can tell, your practice guide, it's the exact same number of questions on your test. Basically, all I did was just go through, pick the different problem that maybe was in the homework that we did, slap it on there. There's a couple of different problems when you get to the back side where there's a little more, in depth. Where it tells you, it asks you questions about a table. I remember, if you remember doing some of those in class. Or if I give you a graph, can you answer certain questions about the graph? Like, does it have an x-intercept? Does it have a y-intercept? Does it have a max or a min? That type of thing. So I thought those were kind of easier questions that we talked about the last couple days in here. And then the last one, obviously, is the stuff we're doing like now, which is differential quotients. So you can see that. That's all the kind of stuff that's on the test. First page, this is really what I want to get through today. I want to get through the first page. And then once we're done there, perfect. And then I want to talk about number 57 on the homework. Because I know I've had a lot of questions on number 57 over the last couple days. Because it's different than the ones I've shown you in class. And I want to discuss it so you know what you're doing right or what you're doing potentially wrong. So we'll go to that. All right, so let's talk about these. The first page, do you notice? It's all factoring. We did a lot of that. It's one of every type. Expect something very similar to that on test day. You have to show me that you know how to factor every specific way, okay? So on the top one, trinomials. What are the rules? What do we talk about? How many parentheses, or what do we do? Is it factorable? Maybe we should talk about that. Trinomial, I agree, it's a trinomial rule, but how do we factor it if it's factorable? 2 parentheses, okay. Start there. 2 parentheses. Now what? Okay, both minus signs. The reason why. This plus sign says they're the same, and they're both minus signs. Because they're the same. That's what the plus sign in the back tells you. They have to be the same operation. And what they are, you look in the front, and that's what they both have to be. That's what the plus sign tells you. Okay, now, how do we break up x squared? X and x. How do you break up 45? 9 and 5, and that will make the 14 in the middle. Now, this is a traditional one. That's a traditional trinomial. It didn't have a number up front. I know, like on your worksheet you had last week, I gave you a problem where it was like 18x squared plus 27x, and it was like a plus 4 or something like that. Bless you, ever season. It was something like that. This number, when you split it up, and this number both work together to make the 27. So when you split it up and you break up the 18 in the front, and you break up the 4 in the back, when you FOIL it, they will make the 27. So it's a lot of trial and error. This is the type of problem I would be worried about. Because it takes time. You have to figure out how to do it if it's even possible. There's lots of combinations, because you can break up 4 different ways. You can break up 18 different ways. And when you put them in the parentheses, it matters where you put them. So that's just something you need to be aware of. I'm picking a problem from your homework that was a trinomial at random. So basically it's just, I look at what problems I assigned, I kind of pick one out, that's a trinomial, that's the one I just put on the test and I hit print. It's pretty easy, I don't put any rhyme or reason into the thought of it. All right, questions. I'm gonna zoom in here. I'm gonna make sure this is bigger, it's a little small. Wow, that's big. Okay. You zoomed in on that one. Okay. Difference of squares. How do we do that? Somebody else now. Thank you, Mr. Ram. Say it again?
2 binomials.
2 binomials.
Plus and minus.
Plus minus. Good. That's a good start. This is how you do difference of squares every time. It's got to be plus minus. 2 parentheses. Kind of like a trinomial. Now, this should be the easiest one out of all the ones on the front page. What do we do?
6x squared.
Okay, 6x squared. 6x squared. Let's say break up 36 evenly. How do I break up that? Say it again? 7y and 7y. Yeah, you break up the front item evenly, you break up the back item evenly, you don't even have to think about it. That's the answer. When you FOIL that, the middle terms will drop out. It works out perfectly. Difference of squares are the easiest thing. They should be perfect squares. You just break them up by whatever the square root was. So, all right, questions on how I did that? That was good. Thank you for the volunteers. So number 2 should be the easiest problem in probably the whole test. how you break it up, how you separate it. All right, questions on the top two, so I'm going a little fast for you. I tend to do that. All right, let's move on to number 3. All right. So number 3, we have to factor using the cube rule. Now in this one, it could be a sum or difference, but it's cube numbers. So, somebody now, please. Cube rule.
You have a binomial and a trinomial.
Good. Small parenthesis, big parenthesis. Good. I agree with that.
And then you look at the symbol in the middle.
Yep.
And then you use SOAP.
But yeah, use the SOAP acronym. The same operation stays right here, and it goes opposite and always positive. That's SOAP. Same, opposite, always positive. That's what SOAP stands for. So same symbol, or the symbol stays. That's how I always think of S. Stays, then goes opposite, then plus. Always a plus in the back. Now, once you have those symbols established, you don't have to worry about the symbols anymore. You don't have to worry about, oh, I have a positive or a negative number here. No, no, no. You've already established the plus or minus signs. It's taking care of itself. You don't need to worry about them anymore. That's the part that really confuses people. They think that even if this is a negative, and you do the rule where you find the middle and you're multiplying numbers together, like, oh, I got to make it negative. No, no, no. You've already made the plus or minus signs in your problem. You don't have to worry about what they're going to be later on. Okay, now for 8x cubed, I need to take the cube root of that. So what's the cube root of 8? 2. Somewhere multiplies on itself to give you 8, so 2. And x to the third, x. You just divide the powers by 3. So whatever the power is on the variable is divided by 3. So this is going to be a 2 and an x. Okay, what about the 125? No, 5. It's 5 times 5 times 5 gives you 125. Yep, small numbers. So it's whatever number multiplies on itself 3 times to give you that. They'll be perfect cubic numbers. You'll see them. Now, the reason why this is important, if you can establish the first parenthesis, like get that first bubble, the rest of it's super easy. But you got to get the first one. So now, the rest of it, you have to square the 2x. So put power 2 on both of those. What does that turn into if you square both of these? 4x squared. That goes in the front. I'm going to square the 5. Well, that's 25. So you square the front, square the back. That's what goes in the back parentheses. So I'm using those two numbers. The middle item are those two numbers right here in this parenthesis. You take these two numbers, whatever they are, and you multiply them together. So what's 2x times 5? 10x. And that's it. You're done. Move on to the next part. I don't care if it's a negative number. I don't care. You've already established the plus or minus signs. Ignore the plus or minus signs after that. Just multiply the numbers or variables, whatever they are. Questions? Okay. Let's go to number 4. All right, number 4, we have grouping factoring. So grouping. So this is the tough one. This is the one where you have to really kind of focus on what you're doing. So how do we want to group?
Group the x's together and the 5's together.
Yes, exactly. You could rearrange and stuff, but on this problem, you identify kind of what matched. Front's the back match. So pretty straightforward. Now, when you factor those things out, so because you're going to group by common factors, what do the first two have in common?
X squared.
X squared. So you're going to factor out an x squared out of the front. When I take an x squared out, there's an x, a minus sign, and a 1. Because you divided an x squared out. That's probably the number one thing people always get wrong, is right there. They forget the 1. You're taking the x squared from both, you're dividing it off, so it turns out to be a 1. Okay, in the back, what do these two have in common? Yeah, take out a negative 5. I know that seems weird. I'm going to factor out a negative 5 back here. So if I divide this by negative 5, that's an x. If I divide this by negative 5, that's a negative 1. It's hard to see that they take out a negative 5. The reason I did that, it made the parentheses the same. That's the goal. Can you get the parentheses to look the same? And if they are, then you've done something right, and you can keep going. So now I'm going to look, what do these both have in common? Well, they have the x minus 1 in common. So if I rip the x minus 1 off, what's left, if the x minus 1's disappeared, was x squared minus 5. You can stop there. If this could go further, you could go further. If it was a trinomial, fine, go further. If it was a common factor, go further. Doesn't matter. Like, I can stop there and I'm fine. All right, questions. That was grouping. I would expect a grouping problem. Something that is factorable. I'm not going to give you some weird prime thing there. I'm going to give you a problem that you can actually do. So I know there was one or two of them that you couldn't even factor, like they just stopped. It really didn't go anywhere. I probably, narrowing it down, it probably won't be one of those. The front one could be, but the top one, number one, because it did say, if the problem's prime, state that. It means you can't factor it. Okay, are we good there? Number 5, this is technically the last problem of the day. I just want to get through number 5 and then talk about number 57 and give you the rest of the time where you can work on your assignment, because it comes you time today. All right, so is there any questions still with 1 through 4? Did I go through it too quick? Did I erase something that you needed? Okay, I'll take silence as either you're scared to ask or you're good. I mean, this first page is super easy for you. That's good. It's good, easy points for you. Okay, factoring completely. This means this problem could be a mixed bag of anything. It could be a common factor, it could be a trinomial, it could be a difference of squares, a cube rule. It could be a grouping that goes down to trinomial rule that goes further. You have to go as far as you can. So it's a mixture of different combinations. So in the beginning, what should I do first?
Common factor.
Common factor. Makes the thing easier. It looks like everything has x squares in it, and everything has a 6 in it. So that's what I'm going to pull out. 6 and an x squared. So if that comes out of this problem, that's going to be an x squared, that's going to be a negative 3x, and that's going to be a 2. If I divide everything by a 6x and a square. Now, can I go further?
Yes.
Yes. Trinomial rule. I can go further. So you have to identify that. The 6x squared just hangs out up here. But this can go further. What's the rule? What do we do? Minus minus?
X and
X and X.
X.
2 and 1, there's no other way to do it. It makes the 3 in the middle. So you have to go until you can't go further. Maybe at this point, maybe this was like a difference of squares. Then yeah, you have to keep going and break that up further. So you have to keep seeing what rules are still there. So be cautious of this last one, number 5. It could go for a while. As long as you're doing correct mathematics. Okay, questions? Okay, you can put your practice guide away. Tomorrow we have 4 problems to do tomorrow. We have 6, 7, 8, 9. They look big and menacing. They're really not, especially those like 6 and 7. They go super quick because you're just answering short, quick questions about a table or a graph. Then those last few, yeah, those can be a challenge. You have to like draw, and you actually have to like do differential quotient. But I want to talk about number 57 today. 57. There was a lot of confusion on 57 because you did all your rules right. So here's number 57. It was something like y equals, or f of x equals 3x plus 7. Something like that. Okay? And the question was, what's your max and min? Do the differential quotient to this thing. What do you come up with? All that good stuff. The differential quotient for this particular problem is super simple because when you plug it into the formula, f of x plus h minus the original function, and you divide by h, the function is super easy because there's no squares. You don't have to like FOIL things together. You're just doing simple distributions. So this actually ends up being this. 3, and then I'm plugging in the x plus h first, right? That's it, right? That's the original function with x plus h plugged in. Then I'm going to subtract the original function in parentheses and then divide it all by h. That's the function with x plus h plugged in. That's subtracting the original function, dividing by h. Notice, it's not very difficult. So what do I have to do next? Distribute. Super easy. Distribute the 3's, distribute the negative signs. Like there's no foiling, nothing weird. So this is 3x plus 3h plus 7 minus 3x minus 7, all divided by h. What happens if you did this right?
You can cancel out everything without H's.
Exactly. Things that do not have h's should go away if you did everything right on the differential quotient. Right? So the 3x's are gone, the 7's are gone, and I'm left with 3h divided by h, which ends up being 3. Okay? You do differential quotient. Simplify it all the way to that, because you last step. Now, in the differential quotient, you know, the back of the book probably has something like that. You check the back, it says that, because it always gives the answer to the differential quotient. It doesn't go further. The question is, you know, what's the max and min on this graph? You know, the absolute max or absolute min, or relative max or relative min if you have multiple hilltops. So the trick was, at this point, you had to try to go further, where you had to try to take and plug h as 0 and take the function and set it equal to 0. Well, what's the issue? There's no h and there's no x. You're absolutely right. There's no h to plug zeros in. You can see it's just 3. And there's no x to solve for. So if you set that equal to 0, you have 3 equals 0 and that doesn't work. That's non-existent, because this problem has no max or min. That's what this is proving to you. You can see it right here. When you try to do the rest of the work, you get this, which is not true. So that's telling you that it doesn't have a max or min. Well, duh. Think about it for 2 seconds. What is that? It's a line. It's not a curve. So it doesn't have a max or a min. Because that thing would start at 7. If I were to draw this thing, it would start at positive 7 on the y-axis, go up 3 and over 1. And it would be a line. There's no max or min to lines. They don't curve. They just go up forever and down forever. So it makes sense the differential quotient didn't give you an answer. Questions with that one? Sorry, just kind of a trick question. The rest of them should have them, because I think the rest of them are curves, correct? They're all like x squares stuff. Anything that has a power of 2 or higher as a curve, they probably have max or mins. Those are all the rest of them. I just thought it was an interesting round to pick. Sorry. It was the first one right off the bat. I give you a trick question, right? All right, but there you go. You can see the work. That's the work I'm expecting to see. You don't have to draw any of them. I just wanted to show you that. Okay, questions on 57 now. Okay, we have that page 75 is due tomorrow, so keep that in mind. Get that done. And then your practice guide, we're going to work on the second half tomorrow. Okay, that's it. This is Thursday.